Hello, my name is Madeline Kenyon, and I am an undergraduate in biological sciences in the Honors Tutorial College. This is How Much Wood Can a Beaver Chuck? Developing monitoring protocols for beavers in Ohio. The focus of this project is the American beaver, known as an ecosystem engineer. Beavers build dams, and the impacts of beavers on the environment is significant, whether that be on vegetation, other animal species, water quality, and water levels. Beavers were extirpated from Ohio by 1830 due to overharvesting from trapping and hunting, but have since recolonized the state. This study is important because while a significant amount of data on beaver occupancy in colonies has been collected recently, monitoring beaver populations is done using ad hoc methods that are rather coarse and may not capture population dynamics well. As such, a habitat modeling framework using the data collected by the Ohio Division of Wildlife would help to implement an updated and effective monitoring strategy for beavers in Ohio. With this project, I will create occupancy and suitability models for beavers in Ohio to recommend an effective monitoring strategy to management. I plan to use previously collected beaver lodge data, aerial survey data, and environmental spatial data extracted from GIS. We will be using the multivariate process of more than 50 25 by 25 mile plots across Ohio, which are ranked as low, moderate, or high suitability based on aquatic habitat availability. These plots have more than 10 years of counts of lodges and colonies collected via aerial surveys. I will use the colony counts in conjunction with spatial environmental data such as wetland habitat, land use cover, vegetation type, stream network, and human and road as predictors of beaver suitability. These predictors for habitat suitability are based on my review of existing literature. Once these data will be extracted at the level of each plot, will use statistical models for count data to predict the number of beaver colonies and their dynamics across the state, and test these predictions against the ad hoc rankings of low, medium, and high. Thus, this study will effectively correct potential biases in beaver habitat classification by incorporating many sources of data in a predictive model. Based on these predictions, I will be able to create maps that will forecast high suitability habitat for beavers that is still not colonized and assess the expansion of beavers in Ohio. The hope for this project is to detect potential changes in populations and increase the accuracy, cost effectiveness, and power of the current monitoring protocol. Ultimately, this work can inform the sustainable management of Ohio's beaver populations and ensure its long-term viability. Indirectly, by allowing beavers to reach their full habitat potential, this research will help inform decisions that allow for great biodiversity, typically associated with beaver ponds, to thrive in Ohio.